Good evening, all of you. Today we will see your sixth practical, which is a investigation of a fin subjected to convection field and base temperature. Now we will move to the regime of two-dimensional. Let's draw a fin like this, which will have a length of 100 plus your roll number. So in my case, I am considering my roll number as 50, so it will be 100 plus 50. One is subjected to a temperature of, let's say, 700 Kelvin, and the fin is subjected to a convection field having a coefficient of convection of H 10 watt per meter square and a temperature of 300 Kelvin. Here we need to convert this watt per meter square into watt per mm square. For that we will multiply it with 10 raised to minus 6 so that it will get converted in mm. As it is a case of steady state, we will require only one material property, which is thermal conductivity, and which is 40. Now we need to define a cross section. Here we will assume that as it is a planar element, it will have a thickness of 1 mm and a width of 50. So let's model it. Choose thermal in a preference. We will need to choose a element type, which is go to solid and choose this one. This is a planar element 55, which has a capacity to conduct as well as have some convection heat loss. Here we need to define a thickness. For that, first we need to activate that. For that, click on option, and here you have to choose this plain thickness so that we will be able to input the thickness. Now click OK, close it. Now go to real constant and here add a thickness of 1 mm. Now define a material property. For that, go to material property, material models, and here go to thermal conductivity, simply isotropic, which is 40. Now we will convert that as per mm, so simply divide it by 1000, click OK. Now modeling, create. Here we can directly create the areas. For that, go down, click on areas, and here create a rectangle by two corners. One corner will be at 0 and we have to measure it diagonally. Go back to paint. This will be 0 0 and it is asking for this corner, which will nothing but 150 into 50. And here we have added a width and height. 0 0, it will width will be 150. Okay. Now we have created a 2D element. Now mesh it. Mesh attribute will be as it is. Instead of clicking line or any key point, we'll directly click areas. Here we will define the length, which is 10, and now mesh it. So this is your so this is we have made the texture. Now we'll apply loads. Go to define loads, apply thermal temperature on a lines. So here simply add temperature of 700 Kelvin. Okay. Now we need to apply the convection field on lines. Pick up the all lines, click OK. The coefficient was 20 divided by 1 into 6 zeros, nothing but 10 raised to minus 6. We have to define the temperature, which was 300. Click OK. So we have created our geometric model. Now simply click on solve. So we have the solution. Now go to general processor, plot result, control plot, and model temperature. So you can see that there is a gradient. The upper surface is cooled down as per the convection field. So this is all you required in your SIG practice. Along with this contour plot, you need to add two more things. First is you have to list the key points so that I will know what is the dimension of your fins. Its length is 100 plus your roll number. The total will be 150. Another thing is you need to list the loads. As we have applied a surface load, it will be under surface and we have applied on all lines. So I will get that things here. So you have to apply three things. One, where I will get a surface load details. Second will be the list of the key points so that I will get the dimension of your fin. And the last one, this your control plot.